This is question Q2 part 2a. How are DTFS and DFT equations related? So remember that this notation here is the DFT coefficients, and DFT coefficients x of k is generated by FFT or DFT of small little x. That's it. Now, once you have the DFT coefficients, all you need to do is divide it by n and you get ck. Okay, so therefore, since xk is FFT, so it's 1 over n FFT x. That's it. Now, if you are given ck and you want to get xn, you can use inverse fast Fourier transform. But before that, this expression here must be xk. So to get ck to xk, you must multiply by n. Okay, so that's all there is to it. This is the relationship of ck to xk. Okay, so not ck is nothing but a what do you call that? A scaled version of xk. Now, the second part is discuss the key consideration when using DFT. Now, DFT. So basically, I have n samples, and I take these n samples out, and we have n sample of xn, and I don't know what is happening outside these n samples, but I can still use these n samples and perform DFT. When I'm performing DFT, DFT is actually exactly like DTFS, right? Except that it's a scaled version. So DTFS is assuming that this guy is periodic, but DFT, we simply take this and then we perform DTFS. So the idea is this: DTFS is only applied to periodic. DFT, on the other hand, take n sample and treat it like it's periodic. Okay, so when the situation or when the sequence is not really periodic, outside these n samples, we actually have no idea what's happening. So you must be very careful that when we perform the inverse DFT, it is only valid, this number is only valid from 0 to n minus 1, the n sample of it. Outside it is not periodic, and we have no idea what's the value. This is unlike DTFS, where it is really from a periodic sequence, and then we can see that this sequence is keeping on repeating. So that's the key consideration when we are taking a DFT. Inverse of DFT, we cannot consider sequence outside this range. And therefore, when we are performing convolution using DFT, you will realize that later on you must pad enough zero to overcome the problem of circular convolution. Okay? So these are the key considerations when applying DFT. Alright, with that, we are done with question 2. Thank you.